So we installed the Tidyverse package and a handful of other packages. My R crashed on me, so I've restarted it. You'll see that there's nothing here. Since we've already installed the packages, we don't need to install them again. However, we do need to call them back if we want to use them. So library tidyverse. So this calls a library and makes sure it pulls it up and uses it. The first thing we'll do is to use a data source within the ggplot2 package. There's a data set called MPG. So let's take a look at that. ggplot2 MPG. This pulls up a data frame. A data frame is a rectangular collection of variables in columns and observations in rows. The MPG data frame contains observations collected by the U.S. Environment Protection Agency on 38 models of cars. So you can see it has the manufacturer, the model, the size of the engine, which is the displacement, the year it was built, the cylinders, number of cylinders, the transmission, the drivetrain, the miles per gallon you get in the city, miles per gallon you get on the highway. I'm not sure what this FL column is, and then finally you have class. What we want to do first is to draw we want a chart, a scatter chart, to see what the relationship between the miles per gallon highway and the displacement size is. I'm sure you know the relationship already is, the bigger the engine, the less highway miles you get. But let's get a little more precise. What's the relationship between this engine size and fuel efficiency look like? Is it positive, negative, linear, nonlinear? So let's jump in and create our first graph. I've put this code in the in my clipboard. Pause the video if you need to read it all and plug it into your R console. Once you hit enter, the results will bring you to a chart, to a scatter chart that has highway on the y-axis, highway miles on the y-axis, and the size of the displacement on the x-axis. The plot shows a negative relationship between the engine size and fuel efficiency. In other words, cars with big engines use more fuel. Does that confirm or refute our original hypothesis? With ggplot2, you begin a plot with the function. So let's take a look at how we create this graph. We start with the function called ggplot, and then within that function we say what we want to plot. Where's the data set? And then within that data set, what type of chart do we want, and what are the variables that we're pulling in. Next, let's use that same data set and same plot to see items that are falling outside the range. So what we want to do is we want to look at this same data set by class. To do that, we come back to our console and we add one more variable to the color. So we have x-axis, y-axis, and color equals class. Remember, class is a column in our data set. Let's close this out and let's look at the results. Now you can see that the color of each bubble, each point, is based on the class of the car. So to map an aesthetic to a variable, associate the name of the aesthetic to the name of the variable. ggplot2 will automatically assign a unique level of aesthetic, here a unique color, to each unique variable of the variable, to each unique value of the variable. A process known as scaling. ggplot2 will also add a legend that explains which levels correspond to which values. The colors reveal that many of the unusual points are two-seater cars. These cars don't seem like hybrids and are in fact sports cars. Sports cars have a large engine like SUVs and pickup trucks, but small bodies like midsize and compact cars, which improves their gas mileage. In hindsight, these cars were unlikely to be hybrids since they have large engines. So you can see the two-seaters they're the outliers over here, and you can see that they have large displacement and significantly higher. They have higher highway miles per gallon because of the size of the car. That's how to identify outliers and assign classes to them. Take a look at this video, review all the options, play around with the MPG dataset, and then we'll start with the next video on how to create more classes within your outputs.